Hi guys, hello everyone. This is Saurav here and welcome to the Vedantu VOS channel. In today's session, we'll be discussing a beautiful concept of organic chemistry which is known as the non-classical carbocations. Carbocations के बारे में आप general organic chemistry में थोड़ा पढ़ोगे, but before that, you should be aware of few concepts related to bonding. If you are thorough with bonding and you are thorough with general organic chemistry, then this will help you understand a very unique and corner case of carbocations in general. So when we study carbocations, we come across something which is known as a classical carbocation. The carbocations that we usually encounter are the classical ones. Why do we call them classical ones? Classical usually हम इस तरह से डिफाइन करते हैं कि जो कार्बोकैटायंस को हम लोन पेयर से और कार्बन हाइड्रोजन सिग्मा बॉन्ड्स और with pi electrons we can stabilize them, then we can call them classical carbocations. What is a carbocation? Basically, a carbocation is a carbon which is electron deficient and has a positive charge on itself. For example, this. There could be three different groups. These groups could be alkyl, these groups could be aryl, these groups could be hydrogen. If this carbocation is stabilized by a lone pair of electrons, for example, like this. If you look at this carbocation, then it is stabilized due to conjugation of electrons from oxygen, which results in the formation of this canonical form. Okay, उन कार्बोकैटायंस को जिनको लोन पेयर से स्टेबलाइज किया जा सकता है उसको हम इंक्लूड करेंगे क्लासिकल कार्बोकैटायन की कैटेगरी में. CH sigma bond electrons, this is nothing but hyperconjugation. In hyperconjugation, what happens is that a carbon hydrogen sigma bond electron moves towards a carbon with a positive charge and it results in this form. You get this. This is again a situation where electrons have moved to stabilize the positive charge. If I want to talk about what kind of orbitals are involved in performing this, then we can say that a CH sigma molecular orbital is overlapping with empty p orbital on कार्बोकैटायन. इसलिए क्योंकि ये जो बॉन्ड है ये सिग्मा बॉन्ड है, दिस बॉन्ड इज अ सिग्मा बॉन्ड, और सिंस ये एक मॉलिक्यूल है तो ये सिग्मा बॉन्ड एक मॉलिक्यूलर ऑर्बिटल की फॉर्म का हिस्सा रहेगा, एंड देयरफॉर दिस MO ओवरलैप्स विद एन एम्प्टी p ऑर्बिटल. यहाँ पे कार्बोकैटायन की हाइब्रिडाइजेशन sp2 होती है, which causes one of the p orbital to remain unhybridized, and therefore that p orbital participates in overlap over here. Another example is when pi electrons are in conjugation. For example, if I take a allyl carbocation, so these pi electrons will move over here, which will cause the creation of a positive charge on the terminal carbon, and आपके पास ये आ जाएगा. So ये तीन एग्जाम्पल हम ना काफी कॉमनली ऑब्जर्व करते हैं. Okay, whether we study Wagner-Merwin rearrangement, whether we study allylic rearrangement, or whether we study pinacol rearrangement, इन सारे rearrangements या फिर कोई भी ऐसा reaction जहाँ पे कार्बोकैटायन इन्वॉल्व होता है, then Carbocation tries to become stable by undergoing one of these conjugations. Okay, so if such a conjugation is present, a carbocation would become stable. So ये जो तरीके हैं स्टेबलाइज करने के, ये कार्बोकेटाइन की एनर्जी को डिक्रीज करते हैं. Now, if these are classical मतलब very common, मतलब एक genuine layman terms में मैं ये बोल सकता हूं कि क्लासिकल का मतलब जो कि आम तौर पे ऑब्जर्व किया जाता है, which is observed commonly. Okay, which is observed commonly, which is observed usually. Okay, this is like a classical sense. What is the meaning of a non-classical system? Non-classical system में आप ये देखोगे कि जो कार्बोकेटाइन है, which is it is not conjugated. Okay, आप देखिए कार्बोकेटाइन्स are these carbocations are the ones which are not conjugated. आप देख लो यहाँ ये कुछ examples मैंने लिखे हैं which are of non-classical carbocations, and these carbocations are not conjugated. You can see them. These carbocations are not conjugated. Conjugation का मतलब क्या? Alternate positive charge and lone pair, या फिर alternate positive charge and pi electron. So positive charge, single bond, then pi electrons. So this is not conjugated. This is also not conjugated. This is not conjugated. This is not conjugated. किसी में भी conjugation present नहीं है. इन सारे केसेस में होता क्या है कि this stabilization is due to, you can say, a delocalized CH sigma bond or C double bond C or C single bond C. Now, इस delocalization और पहले वाले delocalization में थोड़ा difference है. Think of these delocalizations as the ones that you were observing in B2H6. In B2H6 आपने देखा होगा कि BH3 when it forms a dimer, then the electrons over here get delocalized in this region, while the electrons over here get delocalized in this region, creating something known as a 3-center 2-electron bond. इसमें जो middle वाला जो hydrogen आपको दिख रहा है, which is this one and this one, these two hydrogens do not form two bonds. What actually happens is एक molecular orbital create होता है which involves or which is spread across this B, H and this B. Okay, एक इस तरह का एक MO create हो जाता है which is spread on the two boron atoms encompassing a hydrogen atom which is the bridging atom. इसी तरह की situations हमें यहाँ पे देखने को मिलेंगे. Okay, we will see all these examples later. And also have 3-center 2-electron bonds. 3-center 2-electron bond का मतलब there are 2 electrons which are shared between 3 nuclei. Okay, ये सारे जो examples हैं काफी commonly observe नहीं किए जाते हैं, so this is being studied as a special case. इसमें ये जो example है इसके ऊपर काफी questions आ भी चुके हैं. इसको हम बोलते हैं cyclopropyl methyl carbocation. And let's start from here. कि इसका why was this studied? इसकी जरूरत क्यों पड़ी हमें नॉन क्लासिकल अप्रोच बताने की? तो जब ना if you see cyclopropyl methyl chloride was solvolized. Solvolized का मतलब इसको ethyl alcohol water के साथ ट्रीट किया गया. Then people observed this as a product. People observed this as a product, and people also observed this as a product. Okay. अब ये तीनों प्रोडक्ट बने कैसे? So पहला वाला प्रोडक्ट कुछ इस तरह से बनता है. एक्चुअली होता यह है कि जब आप इसको इथाइल अल्कोहल वाटर के मिक्सचर में डालते हो, ये it undergoes conversion to this carbocation. And this carbocation has और कैन डू 3 थिंग्स। देखिए क्या क्या कर सकता है। सो द फर्स्ट थिंग दैट इट कैन डू इज दिस कार्बोकेटायन can undergo ring expansion. Ring expansion अगर हुई, then we will get a cation like this, and this cation will further react with H2O and it will lose H plus to form जो कि हमारा प्रोडक्ट ए है। ये 48% हमें मिलता है। दूसरा प्रोडक्ट ये बन सकता है कि दिस कार्बोकेटायन participates in reaction with H2O, loses H plus and creates this alcohol. Now to form this species, this has to be stabilized. इसको stabilize कैसे, जैसे यहाँ पे रिंग एक्सपेंशन होगी तो यहाँ पे stabilization होता कैसे है? What we do is we consider this species to be created like, so आप यहाँ पे 3 कार्बन एटम बनाइए and this is connected to CH2। यहाँ पे 2 हाइड्रोजन है इसके और ये एक इसका p ऑर्बिटल। Now you have to understand कि when you have a 3-membered ring के अंदर जो एंगल होती है वो 60 डिग्रीज होती है। Therefore there is a huge amount of strain और ये जो lobes which are trying to create this bond, if are looked at, ये lobes तब बाहर की तरफ बल्ज करने की कोशिश करते हैं। So it is in fact like this. Okay, let me just make some refinements. And this region जो कि हम ट्राइंगल को दिखाते हैं, एक अप्रोक्सीमेट आइडिया है कि ये बॉन्ड किस तरह से दिखते होंगे। तो यहां पे ओवरलैप हो रहा है, over here overlap is taking place, over here overlap is taking place, and आप ये देख सकते हो कि this part is also fairly coplanar to this p orbital. Okay, there is a fair degree of coplanarity, means ऑलमोस्ट पैरेलल दिख रहे हैं। अगर ये पैरेलल दिखेंगे तो क्या होगा, ये इलेक्ट्रॉन डेंसिटी इधर मूव कर सकती है और अगर ये इलेक्ट्रॉन डेंसिटी उधर मूव किया, ओके, इफ द इलेक्ट्रॉन डेंसिटी मूव्स इन दैट डायरेक्शन, देन कैन वी से हमारे पास कुछ इस तरह का हिसाब बन सकता है कि द इलेक्ट्रॉन्स वुड look like this. कुछ इस तरह का एक सिचुएशन क्रिएट हो सकता है। This form is the one which participates। अब देखिए यहां पे यही बनाया गया है 1 2 3 and 4, एक बॉन्ड को ब्रेक किया गया और एक थोड़ा सा बनाया गया 1 2 3 and 4। So this is what could be a way to stabilize this carbocation, and that, my dear students, is a non-classical participation, because आप ये चीज देखो कि यहाँ पे 2 इलेक्ट्रॉन थे और अब ये इस एटम और इस एटम के बीच में डीलोकलाइज कर रहे हैं. सो दिस होल रीजन, इस पूरे रीजन में ये जो सर्किल्ड एटम्स मैंने दिखाए हैं, in this whole region there are 2 electrons moving between 3 centers, so there is a 3 center 2 electron. Okay, the last one is pretty easy to understand. मान लेते हैं कि ये एक परमानेंट फीचर हो गया, ये इधर आ गया, this is third one. Then what might happen is this, and this one if participates in reaction with H2O, then third one will be formed. Okay, so this is the first type of non-classical carbocation. Next, the next one is known as the methonium ion. Okay, इसको methanium ion भी बोलते हैं. Why it is called methanium ion? Because it is created when CH4 is taken with a superacid. और हम superacid लेते किसको है? We take a mixture of HF and SbF5. Okay, we take a mixture of HF and SbF5. होता क्या है कि HF and SbF5 H+ प्रोड्यूस करते हैं और ये CH4 इस H+ के साथ इंटरैक्ट करने की कोशिश करता है. ओके, जब ये CH4, ये H+ इतना पावरफुल रहता है, मींस दिस सुपर एसिड इज सच अ पावरफुल एसिड that it will try to withdraw, it will remove H- from here, और यहां से कुछ हमारे पास एक CH3 पॉजिटिव और H2 निकल के बाहर आता है. ओके, अब अगर मैंने CH3 पॉजिटिव को ऑब्जर्व किया तो CH3 पॉजिटिव कुछ इस तरह का दिखेगा, कार्बन, and then there is hydrogen, इसको मैं पॉजिटिव चार्ज दे देता हूं इसके ऊपर. एंड अगर इसके सामने, इफ इन प्रेजेंस ऑफ दिस देयर इज अ हाइड्रोजन मॉलिक्यूल, then it is possible that these hydrogen, the electrons present in the bond between 2 hydrogen atoms get delocalized over to carbon atom. ये कुछ इस तरह से. Okay, the shaded region is the one which is the, or the highlighted region is the one which is the electron cloud which has moved, और ये 2 इलेक्ट्रॉन का क्लाउड है जो कि कार्बन की तरफ मूव कर चुका है. ओके, in doing so can I say that something like this gets created? और एग्जैक्टली यही पिक्चर मैंने यहां बनाया है. दिस स्पीशीज इज मेथेनियम आयन, और इस पूरे रीजन में, ये जो डॉटेड लाइंस दिख रहे हैं, इस पूरे रीजन में there are 2 electrons which are dispersed. ओके, और स्प्रेड आउट, आप कुछ भी बोल सकते हो. सो 3 न्यूक्लियस, कार्बन, हाइड्रोजन, 3 न्यूक्लियस, एंड उनके बीच में 2 इलेक्ट्रॉन which are dispersed. So therefore we have a 3C2E bond. Okay, 3C2E bond. या फिर आप इसको इस तरह से दिखा सकते हैं कि ये तो हाइड्रोजन के दो इलेक्ट्रॉन आके इस कार्बन के साथ इंटरेक्ट कर गए एंड आपको कुछ इस तरह का सिस्टम मिल जा रहा है. प्लीज रिमेंबर, दीज आर नॉट कन्वेंशनल कोवेलेंट बॉन्ड्स. These are bonds which are created as a result of the delocalization of these two electrons between the carbon, hydrogen and another hydrogen. हम क्या ये बोल सकते हैं कि इसमें HH sigma bond, sigma MO has overlapped with the 2p orbital of carbon, but this HH sigma MO or this sigma electrons are not utilized from within the molecule. कहीं बाहर से H2O से आ रहा है. ओके okay? अगर किसी ने बोला कि इसकी ज्योमेट्री क्या होगी तो आप इसको बोलोगे कि ये एक TBP अरेंजमेंट में प्रेजेंट रहता है. ओके, now please remember, do not say that it is sp3d hybridized. The appearance is trigonal bipyramidal does not mean that sp3d hybridization takes place. Okay, chalo, let's move on to the next one, which is known as the phenonium ion. Phenonium ion कुछ इस तरह का दिखता है. इन phenonium ion को हम कैसे डिफाइन करते हैं? phenonium ion is defined as a cyclohexadiennyl cation. देखिए, ये cyclohexatriennyl सिस्टम है. साइक्लोहेक्साट्राईन हम बोल देते हैं इसको. ये साइक्लोहेक्साडाइइनाइल है. This cyclohexadiennyl system is spiroannulated. Spiroannulated का मतलब कि अगर इस स्पीशीज को मैंने ऑब्जर्व किया एंड ये मैंने ड्रॉ किया, दिस इज स्पाइरोएन्युलेटेड का मतलब कि जो इन द cyclopropyl system and the cyclohexadienyl system are connected to each other in spiro arrangement. इसका मतलब कि it will look like this. और this part is present in a horizontal plane, while this part is present in a vertical plane. ओके, अगर ये वर्टिकल प्लेन में प्रेजेंट है तो ये हॉरिजॉन्टल में प्रेजेंट है. अगर ये वर्टिकल में प्रेजेंट है तो ये हॉरिजॉन्टल में प्रेजेंट. सो दे आर इन द फॉर्म ऑफ अ स्पाइरेन यूनिट. ओके, दिस इज अ फेनोनियम आयन. ये फेनोनियम आयन को हम ऑब्जर्व कहां करते हैं? वेरी इंटरेस्टिंग रिएक्शन दैट वी ऑब्जर्व is a reaction like this. pH, C, H, H, C, can take Me, H and OTS, tosyl unit. When this goes out, okay, यहां पे एक कार्बोकैटायन ऐसा कुछ बनता है. This pH comes over here and it looks like this. Okay, this is where we observe a phenonium ion. When there is a phenyl group which can migrate and is present at alpha position with respect to a carbocation, then we observe a phenonium ion. This is observed very commonly in pinacolone rearrangement or any other typical carbocation rearrangement in which the alpha position has a phenyl unit. Okay. The next one is the non-Bournonile ion is or non-Bournonile system in which there is a pi bond assistance. इसको समझने की कोशिश करते हैं. जैसे कि ये कंपाउंड आपने देखा कि यहाँ पे OTS है. This OTS is a good leaving group. This OTS is a good leaving group. When it leaves, I'll get a carbocation over here. Okay, I'll get a carbocation over here. इसी पोजीशन पे ACO आके अटैक करता है. ACOH मतलब एसिटिक एसिड से जो एसिटेट निकला था वो आके यहाँ पे अटैक कर रहा है. Now if you look at the K1 and K2 of both of these reactions, okay, if you look at the K1 and K2 of these reactions, you will find that the K2 is very large as compared to K1. ऐसा क्यों? तो इसको समझने के लिए हमें यह समझना होगा कि what actually happens in the course of reaction. So this is your system और यहां पे कोई OTS present है. Okay, now if I draw the molecular orbitals or the orbitals which are actually interacting, हम क्या इसको इस तरह से दिखा सकते हैं. OTS is connected over here. And over here we have a pi bond. अब देखो इसको निकालने के लिए to remove OTS I need to donate electrons in the anti-bonding MO. Okay, इसको मैं थोड़ा छोटा कर देता हूं so that it will be easier for you to understand. Whenever a bond is being broken, then electrons are to be provided to the anti-bonding molecular orbital so that the bond is broken. तो ये इसका ABMO. This ABMO is present in such a fashion that this ABMO can receive these electrons quite easily. यहाँ पे 2 pi electrons present है. ये pi electrons इसके पास आ सकते हैं. Okay, and if they come over there, then what will happen is that OTS will go out and such a situation will be created. Okay, such a situation will be created. इसको हम exactly इस तरीके से दिखाते हैं. और यही बन गया आपका non-Bournonile ion in which there is a pi bond assistance. So अब देखिए इसकी जो orientation है that is very important. जिधर से ये निकल रहा है, मतलब this has to be, it has to look like it is it is opposite with respect to the direction of orientation of the pi molecular orbital. So this is the pi MO, which is pushing out the OTS, and therefore K2 becomes fairly large क्योंकि there is an assistance which is being provided to this ion from these pi electrons. Exactly same चीज हम नॉन बोर्नोनाइल के साइक्लोप्रोपाइल रेसिस्टेंस में ऑब्जर्व करते हैं. देखो OBS निकल रहा है without any assistance. OBS is going out and there is a cyclopropyl system which is present over here. तो यह साइक्लोप्रोपाइल ने इसको कुछ असिस्टेंस प्रोवाइड किया and therefore can you see that the rate is so large. यहां पे असिस्टेंस प्रोवाइड करने के लिए the orbitals are not in proper orientation, but over here it could happen, but the orientation of OBS is not good. OBS is a good leaving group. So if I were to show the cyclopropyl assistance, the cyclopropyl assistance would be shown exactly in the same way. Okay, the cyclopropyl assistance would be shown exactly in the same way. मान लीजिए कि इस तरह से आप दिखा रहे हो. So this is OBS. There's OBS present over here. So now can think of the interaction to take place like this, which would cause this kind of a situation to develop. आपको ये समझना है कि the cyclopropyl behaves like a pi bond. Okay, the cyclopropyl behaves like a pi bond, and just like how pi bonded system provided assistance to the carbocation, the cyclopropyl system will also provide the same kind of assistance. So आपके पास यहाँ पे एक positive charge आ जाएगा, and there, since there is an assistance, so now you can see that there are two electrons which are delocalized. So this is again a region of 3 center 2 electrons, and because of which this will be also known as a non-classical carbocation. Okay, so I hope you understood whatever I discussed today. Please do write to me on saurav.goswami@vedantu.com in case you face any issues. This is something which is slightly dense and which is usually not taught in general organic chemistry classes, but I hope you will be able to appreciate this. So that's all for today, guys. Have a lovely time and let's meet each other in the next session.